According to the Florida Geological Survey, in the Bay Area, sinkholes of all sizes are most likely to open up.
Sinkholes. What you may not know is that there are also holes underwater in the ocean.
What if the ocean floor near Florida is slowly collapsing and most people have no idea it's happening? What if deep beneath the Atlantic waters, scientists are finding massive underwater holes that could change how we understand the stability of America's coastline? Recently, marine researchers discovered enormous oceanic sinkholes, some hundreds of feet deep, hiding just offshore. These are not ordinary formations. They are ancient geological structures filled with strange chemistry, unknown ecosystems, and clues about Earth's past. And what scientists found inside some of these underwater voids was completely unexpected, because these formations may be telling a much bigger story about how coastlines change over time. When most people think about Florida, they think about beaches, tourism, and warm ocean water. But beneath those waters lies something few people ever see: a massive limestone foundation that has been slowly shaped by water for millions of years. The entire Florida peninsula sits on porous carbonate rock, which means water can slowly dissolve it over time. This is why Florida is famous for sinkholes on land. But what many people don't realize is that similar processes also happen underwater. Off the coast of Florida, scientists have identified dozens of deep underwater formations known as blue holes. These are essentially giant submerged sinkholes. Some are narrow, some are extremely wide, some drop straight down like vertical tunnels into darkness, and many of them remain unexplored. That mystery is exactly why marine scientists began taking a closer look. Researchers from the National Oceanic and Atmospheric Administration and university marine programs began detailed mapping projects using sonar imaging and robotic exploration vehicles. Their goal was simple: map the unknown. What they found was surprising. Several blue holes appeared much larger and deeper than expected. Some showed unusual chemical signatures suggesting unique environmental conditions. Using remotely operated vehicles, scientists descended into some of these underwater cavities. What they found raised new questions: layers of water with very different oxygen levels, strange microbial ecosystems, and sediments that may preserve environmental records thousands of years old. For scientists, these formations are not just geological features, they are time capsules. To understand why these discoveries matter, we need to understand how these formations develop. Thousands of years ago, during ice ages, sea levels were much lower. Areas that are now underwater were once dry land. Rainwater slowly dissolved limestone, creating caves and underground chambers. Over time, ceilings of these chambers collapsed, forming sinkholes. Then, as glaciers melted and sea levels rose, the ocean flooded these formations. Today, they remain as vertical underwater caves. Some researchers compare them to flooded skyscraper shafts, deep, narrow, and filled with layers of water that do not always mix. And this is where things become scientifically fascinating, because inside some blue holes, scientists found water layers with almost no oxygen. These environments are similar to extreme habitats found in deep oceans, and life that survives there must adapt in unusual ways. When exploration vehicles entered some of these formations, they detected unusual biological activity: microorganisms that survive with very little oxygen, bacteria that process sulfur and methane, sediment layers that may record hurricane history. These findings help scientists answer important questions. How does life survive in extreme environments? How does ocean chemistry change over time? What can these environments tell us about early Earth? Some researchers even believe these environments may provide clues about how life could survive on other planets with extreme conditions. But there is another reason scientists are interested: structural stability. This is one of the most common questions. Right now, scientists say there is no evidence of sudden collapse risk affecting coastal cities. Most underwater sinkholes formed thousands of years ago and appear structurally stable. However, long-term monitoring remains important. Geological processes can be extremely slow, sometimes occurring over centuries. Understanding these formations helps scientists track how coastlines may change in the distant future. Monitoring also helps researchers understand how groundwater movement interacts with ocean structures. This is not about panic. This is about preparation and understanding. Florida's geology makes it one of the most sinkhole-prone regions in North America. That is because limestone dissolves easily compared to harder rock types. Freshwater movement underground slowly creates cavities. Sometimes these cavities collapse on land, forming sinkholes people see in news reports. Underwater, The same process can create much larger structures because there is less pressure from surface weight. This makes Florida one of the most important places in the world to study sinkhole formation, because what scientists learn here can apply to other coastal regions globally. As often happens, discoveries like these quickly spread online. Headlines sometimes suggest dramatic scenarios. But scientists stress something important. Discovery does not mean disaster. Finding these structures helps improve knowledge. Better knowledge means better planning. Better planning means reduced risk. Scientists emphasize that most blue holes remain stable and are part of natural geological evolution. In other words, this is science doing its job, finding things early, understanding them early. So society is never surprised later. Marine scientists plan to continue exploring these formations using new technology. Future missions may include high-resolution 3D mapping, chemical sampling, microbial ecosystem studies, long-term movement monitoring. Improved underwater robotics is making exploration safer and more precise. And every new expedition adds another piece to the puzzle. Because even today, scientists estimate that more than 80% of Earth's oceans remain unmapped in detail, meaning discoveries like these are likely to continue. This discovery is not really about sinkholes. It is about understanding Earth's hidden systems, how land changes, how oceans interact with geology, how life survives in extreme conditions, and how coastlines evolve over time. Florida simply happens to be one of the best places to observe these processes in action, which makes it a natural laboratory for marine geology. And discoveries here could help scientists better understand coastal risks worldwide. The discovery of massive underwater sinkholes near Florida is not a warning of immediate danger. It is something far more important, a reminder that even in the modern world, much of our planet remains unexplored. Beneath calm ocean waters are structures formed over thousands of years, hidden caves, ancient chambers, geological stories still being uncovered, and each discovery shows how dynamic our planet truly is, not chaotic, not unstable, but constantly changing. And as scientists continue exploring the waters off Florida's coast, one truth becomes clear: the biggest discoveries on Earth may still be waiting beneath the surface.